Right, we'll make a start. Morning, everyone. I'm Paul Wright. I'm part of the estimating team at Swarco Traffic. The purpose of this webinar is to highlight insights for speed, junction, and hazard warning solutions, and basically share some of the points and details that we've learned over the years to help you with assessing current schemes and new schemes that you may be looking at. I'd like to start with a resume of the planned topics that we'll be dealing with on this webinar. So as you can see, we'll start with a brief introduction to Swarco. We'll have a section on standard vehicle activated signs, or VAS. We'll have a small section on TSRGD and sign design. We'll have some details on road design hazards and some use cases in action. There are warning systems for natural hazards, and then a segment on vulnerable road users. And then we'll finish off with a small section on off-grid solutions and a Q&A. Everything okay? Good. Right. An introduction to Swarco. For those of you who are unaware of the company, or those of you who may have only dealt with us on a specific item, I'd like to take this opportunity to start with a brief overview of the company. Swarco was founded in 1969 by Manfred Swarovski of the Swarovski family, who created a company to manufacture glass beads for the road marking industry. Since then, the business has branched out into development of leading technologies for ITS, road safety, traffic signals, product development for car parking, including electric vehicle charging infrastructure and bespoke safety solutions, consolidating its reputation as a market leader both in the United Kingdom and across Europe and the Nordic regions. Swarco is a world leader for technological solutions for road safety, with partner companies and subsidiaries in 25 countries around the world, a customer base in 70 countries, including 3,800 employees and mobility expert partners. The key to any road sign is that it's logical and intuitive to ensure that drivers are able to access and assess information almost unconsciously. Having said that, we all understand that while drivers are rightly concentrating on the road, the surrounding traffic and the conditions around them, it's easy for drivers to become blind to some of the instructions and requests that they receive from the roadside signs and related messages. VAS, or vehicle activated signs, is a technology that has developed in recent years to prompt drivers to awareness of the restrictions or hazards as they approach them. Speed warnings for urban approaches, your speed or driver feedback signs to make drivers aware of their speed at that moment, or other warnings such as proximity to a school or pedestrian area are all examples where a vehicle activated sign, or VAS, could be deployed to assist a driver with an intuitive reminder of the specific hazards they may encounter ahead. In its simplest form, a VAS uses a microwave vehicle detector, or MVD, to identify an approaching vehicle that is travelling above a preferred speed, and then trigger a display to highlight the hazard to the driver, whether it be excessive speed or a specific hazard. The controller itself is relatively simple, allowing the user to define a speed threshold, the speed at which the device will activate, along with the period of activation. An alternative to the defined activation period is to allow the sign to remain active whenever the vehicle is in the zone of detection, which is the area in which the MVD sees the vehicle as it moves toward the sign. This is typically from around 100 meters to within 20 meters of the sign location, ensuring that the approaching driver is highlighted to an imminent hazard, and this warning stays visible until the driver passes the sign and enters the hazard zone. Standard VAS are a relatively simple design of controller, including in some cases a rotary switch to pre-select the display and detect a speed offset on a multi-speed sign. This control arrangement is used in our range of movable VAS to allow the end user to deploy the sign at an agreed location and then set the speed of activation and display to suit. The sign is supplied with a Bluetooth interface to allow download of log data from the MVD and upload of controller configuration via the Bluetooth link. The sign components are DIN rail mounted to allow easy servicing and maintenance of the sign in the event of a failure if a rail mounted component is established as the cause of the fault. And effectively, that's about the extent of simple MVD activated VAS. Approaching vehicles activate the sign display based on a preset threshold. The controller configuration is stored on a small onboard memory, and the MVD can be utilized to provide log data to inform the client on traffic flows, traffic behavior, traffic volumes, and counts. Simple VARs are still an important part of an ITS infrastructure where speed or a static hazard, such as a bend ahead, are a permanent feature. And the best preparation a driver can receive is to make them aware of the hazard along with a message to reduce their speed. Don't forget, if you have any questions about this section or any of the subsequent sections in the webinar, please feel free to leave them in the chat and we'll address them in the Q&A at the end. Following increased customer focus on value for money and desire for more functionality for VAS products, Swarco began a development program back in 2014 to design its own sign controller to allow greater flexibility in conjunction with our focus on in-house development and product testing to meet the most rigorous standards demanded by the EU and UK regulations. The result of this development was the Swarco Perfectus controller. The word Perfectus is Latin and was selected as the name of the controller following a competition held for the Swarco team in 2016. The basis of the Perfectus controller is to provide a basic platform for our designers and engineers to install configuration files, provide outputs to displays and radio transmitter equipment, provide either specific or close contact input from a range of devices and systems, including the radio platform, and allow the controller to support the wide range of functionalities within an ever-developing sector. The image on screen shows a Perfectus controlled sign in use. As you can see, the sign is currently displaying the left-hand junction warning, having been activated by the blue vehicle highlighted in shot leaving the junction. While the vehicle has left the zone of detection, the sign is still activated as it has a delay between vehicle movement and display deactivation to ensure that drivers travelling at the full speed allowed on the highway are still warned of a potential hazard ahead, as the blue car would not be expected to be travelling at the full speed yet. As you can see, this sign features dual display functionality. The approaching vehicle in shot is travelling above the set speed threshold, and the sign has been activated via the MVD to warn the driver that they are travelling above the speed limit for this section of carriageway. As there's no presence at the junction ahead, that part of the display is not required. But as the sign can act both as a hazard warning based on the junction presence or as a speed warning based on the approach detection on the MVD, the client is able to extract maximum value on a combination of use scenarios for sign deployment. A closer look at the detail of the Perfectus controller shows us how functionality is supported by a standard format modular controller. The controller includes connections for short-range radio and local Wi-Fi activation, MVD and close contact inputs, along with outputs for activation and display outputs. The board also features an onboard modem to allow remote monitoring of the sign by the client. This functionality allows the client to recover MVD log data, sign fault data, and also upload configuration modifications to the sign from a remote in-station. This is a significant step forward from the usual remote monitoring solutions for VARs, which utilize a third-party modem device with limited information transfer capabilities. The remote monitoring interface is browser-based, so clients and end users are able to utilize existing devices to access the sign network without investment in specialized technology. The board also features onboard storage along with a coin battery to ensure that the configuration and data on the sign controller aren't lost if there's a power failure on the sign supply. Before we get too far into the technicalities of the system design, I just wanted to briefly highlight the sign face design itself. As you probably know, the Traffic Sign Regulations and General Directions of 2016, or TSRGD to give it its more recognizable name, is the main guidance document we all refer to for design and sign layout guidance. As you can see in the accompanying slide, design of all aspects of the sign face is governed by different aspects and items in TSRGD. Some are quite specific, such as the relationship between text heights and the symbol height, for instance, and some are more general to best practice on sign layouts. As an example, the spacing between the symbol and the tile around the slow down text isn't a specific detail to VAS design, but it is a more general detail that is part of sign design, as addressed in Schedule 13 of TSRGD. While Schedule 13 isn't directly applicable to VAS, or discontinuous variable message signs, as they are referred to in TSRGD, it is offered on plate signs as part of the best practice to ensure readability for drivers. For that reason, we adhere to the design element as part of our design process, as we appreciate that while our signs are activated and intuitive, it is still important that they are clear for drivers. So the correct clearance between elements to maintain readability is important. This is also important for spacing between text or symbols and the corner flashing amber lanterns. Spacing of the lantern, again, isn't a VAS specific detail, but lantern spacing is addressed in Schedule 15 of TSRGD as applied to overhead gantry displays. So again, we feel that if there is a recommendation for application of a design feature in a specific environment, and that design feature adds clarity to the message to the driver, then we can apply this guidance to support that clarity with our own displays. We feel it's important that drivers can always interpret information quickly and with clarity, whether it be a simple slow down instruction as the sign here shows, or whether it be a more complex message. If the message requested by the client is not to TSRGD regulations, we will advise on that. And the onus does remain with the client to seek clearance from the Department for Transport for use of a non-standard or non-regulated design. But we will also always ensure that best practice for sign design is applied wherever possible, because better clarity should mean safer roads. To help better with understanding of the various solutions the Perfectus controlled sign and system can offer, we've prepared a series of slides to demonstrate how the hazard warning suite of products can be implemented in real-world situations. The location shown is a real location, Penshire Bridge near Sunderland, built in 1890 by David Balfour for the princely sum of £8,000. I should stress at this stage that we haven't implemented these solutions at this site. This site was chosen merely because it features a host of different potential hazards to which we could apply solutions, and the solutions shown have all been implemented in different locations around the country. So as you can see, this section of road is typical of many urban and semi-urban schemes where we have vehicle interactions. At its most basic level, where vehicles are approaching the junction and are in an urban area, the first thing we can ask a driver to do to minimise a potential accident is to reduce their speed. So a VAS placed on the approach to the area is the simplest solution to a potential hazard problem. With the VAS placed in location, the driver may be warned of their speed, or they could be warned of the crossroads ahead by using the diagram 504 crossroad triangle. So far, so good. Our driver sees a sign to highlight the hazard ahead. Having said that, we know from anecdotal evidence, along with a wealth of independent research and testing, that drivers do become complacent to signs they see regularly, whether they be fixed plate signs or illuminated warning signs. TRL have produced a wealth of information on this subject, and TRL 548 is an invaluable document on the subject. To mitigate this tendency, we can introduce external triggers to the hazard warning sign to ensure that the driver is warned of the hazard when it's appropriate. This is particularly valuable to regular drivers on a route who will become aware of the fact that the message they see is associated to a specific hazard. So in this case, a presence loop is being added to the junction stop line, linked by close contact back to the sign. In this scenario, the sign features the diagram 504 crossroads symbol previously seen, but the sign is only illuminated when there's a presence at the junction and there's also an approaching vehicle, meaning an approaching vehicle that uses that route regularly will see that when there's no junction presence, there's no warning. And in this case, an overlaid display can maximize the sign value to the user. So when there's a junction presence and an approach detection, the junction warning is illuminated. But when there's a speeding approach without a presence detection, the speed warning is illuminated. With the arrangement shown in this slide, we appreciate that the overall cost of a project to the client is increased because there's a large element of groundworks involved in preparing the closed contact input. If a scheme is being designed into a new junction, then this can be accommodated. But as we all know, it is much more likely that the system is being applied to an existing roadway where a hazard scenario has developed over time, whether it be a new development, a change of access routes into an area, or just an increase of traffic volumes. When a hazard solution is being installed in an existing location, the solution we can bring is based on the use of a virtual loop rather than a physical loop with a radio link from detector to display. This brings multiple advantages to the client, as the use of a radio link from detector to display means that groundwork is reduced, disruption to drivers is reduced, noise pollution for the surrounding residents is reduced during works, and the finished site doesn't need the time and upkeep to be returned back to a natural state. Virtual loops can also be used for queue detection, where the speed of vehicles travelling through a detection zone can be assessed, and then a trigger to the prior warning sign can be activated if the vehicle flow drops below a set speed. This is a solution that utilises slightly different forms of the detection, as the ability to measure speed through a detection zone isn't native to all virtual loop detectors. But as traffic volumes rise on urban access routes, detection and prior warning of queuing traffic can help not only to avoid accidents at the busiest times of day, but also help traffic planners as they explore longer-term strategies for traffic management in urban areas, especially as air quality management is so heavily linked to queuing traffic. As with the previous solutions shown, queue detection equipment can be installed at roadside with minimum disruption to traffic flows. And once a new traffic guidance strategy has been implemented, there's nothing to stop a local authority from moving that detection and display equipment to a new location, rather than seeing their investment as a finite solution for a single location, as would be the case with a wired ground loop or a standard close contact activation. As you're about to see in the accompanying video, a junction system has been installed to monitor stop line activity along with approaching vehicle movement. As the stop line detection provides an output via the junction controller to the signs would provide a turning traffic warning in the event that there is a stop line presence and there is a simultaneous vehicle approach above a preset speed threshold. As it is, however, the vehicle seen at the stop line detection at the start of the video doesn't wait because there's a clear space in the traffic to move into. In this scenario, it's correct that the sign would not warn drivers of an obstruction ahead because the placement of the sign in relation to the junction means that the vehicle approaching within the approved speed for the road will not encounter the vehicle leaving the junction. As you can see, the sign is illuminating to warn drivers of their speed, but as there's no requirement to advise drivers of turning traffic, that element of the sign functionality isn't used. The system installed in this location actually covers 4 different detection zones, as shown in this extract from the original scheme request. We have stop line detection of both sides of the crossroads and right turn refuge detection in the middle of the road. Functionality of the system is further enhanced as the right turn detection only causes the oncoming traffic to activate a warning, thus reinforcing the confidence that drivers can have that the warnings presented to them is the actual warning they need, as opposed to a more general junction warning, which can cause drivers to be complacent in the face of a repeated warning without apparent merit. Speed detection and junction hazard detection are scenarios that apply to lots of areas around the country. But in all of the cases we've shown up to now, the hazard is a temporary hazard, such as a speeding vehicle or a vehicle detected at a stop line. We appreciate, however, that some natural hazards can cause significant problems, and in some cases can cause massive immediate and ongoing disruption. A natural hazard in this case is a hazard that's part of the existing surroundings or a hazard that arises as a result of natural or climatic conditions. An example of a system that can be implemented to prevent problems at a natural hazard using virtual detection technology is the Overhyped Vehicle Detection or OVD system. The current slide demonstrates a compact OVD arrangement placed in advance of a low clearance hazard for high vehicles, if we assume that in this case the bridge ahead constitutes the height clearance hazard. The OVD utilizes a pair of crossroad beams with detector to enable directional sensing in conjunction with a ground loop below the beam. When a high vehicle approaches the hazard zone, the beams are broken to establish that the vehicle is higher than is safe or practical for the forward route. In this case, a pair of beams used to provide directional sensing because the beams cover the whole carriageway. Directional beam sensing ensures that the vehicle braking the beam is the vehicle being warned of the hazard, because a single beam can be activated in either direction. So we use dual beams with a ground loop to ensure that all detections are valid as best we can. The detection is backed up with the presence loop to ensure that when the detection is sound, as opposed to debris or leaves in the air passing through the beam, for example. When the beam is broken and there's a simultaneous loop detection to confirm the presence of a vehicle, the detection warning trigger is sent forward to the sign to warn the driver that he can't continue on the route ahead. A diversion route can be offered, either to turn back or to follow a left or right turn diversion. The main factor to remember with preparation of an efficient OVD system placement is that often the diversionary routes are as important as the detection and hazard avoidance itself. While it's theoretically safe and proper to ask a vehicle to turn around as part of a diversion, we appreciate that this can be particularly disruptive for traffic through a detection area. So often it's vital to consider a wider diversion route that utilises the detection and warning sign well before the hazard itself, thus ensuring that the traffic, including the high vehicle, all travel in a regular manner without disruption. OVD systems are an essential part of hazard avoidance on the modern highway, as large vehicles have become much more prevalent on urban and trunk routes. Existing infrastructure such as railway bridges often can't be modified to suit the requirements for larger vehicles, and groundworks to suit the vehicles will be costly and disruptive for extended periods. So a well-planned OVD diversionary route can be an economical solution for highway planners. A route is also prone to weather-related hazards, and this can be just as disruptive to traffic flow. Local authorities or route operators can sometimes be caught out by quick changes in climatic conditions that create a hazard for drivers, and so an automatic warning system can be crucial in not only protecting the local traffic, but also highlighting a developing problem to the route operator remotely. An example of this could be an icy road. So in this scenario, surface-mounted ice detection can transmit warnings of a cold or icy surface to the sign controller, and as with previous scenarios, the input from that detection in conjunction with a vehicle approach can highlight an ice warning to drivers, and if necessary, advise the drivers to divert to another route. Flood detection acts in much the same way. The flood detector is mounted in the waterway and can provide an output by radio to the sign if the water levels reach a point where the route is flooded or is about to flood. As with the ice warning, this provides a message to approaching drivers that the route may be impassable and that an alternative route should be taken. The important differentiating feature of flood detection is that differing aspects of the output from the detector can be used to prepare the messaging. The speed of rise of the water level, for instance, can be used to move directly to the urgent phase of flood warning rather than the standard first phase, which may be more precautionary. The example on screen is the before scenario. As a result of this flood event in Wensleydale, 9 people were involved in incidents that required attendance by the emergency services to rescue stranded drivers. As a result of this event, the local authority have moved to utilise a permanent flood warning solution to ensure drivers are well informed of the hazard both before and during the flood event. With both of the solutions detailed, as previously mentioned, drivers will become aware over time that a triggered system is working with full efficacy based on their understanding that the hazard they are facing actually exists thanks to real-time activation, as opposed to the permanent plate warning sign or risk of ice or of risk or flooding that is either always there year-round and becomes invisible to regular users, or a temporary sign that puts the road operative or local authority in the position that they have to attend site to deploy that temporary signage, which allows the operating authority to deploy those valuable resources elsewhere. Often, once a solution has been implemented, the client can utilize local media to highlight further to the public that a solution to a problem site has been implemented, and that the local authority are providing solutions to help with road safety for local citizens as well as the through traffic. Another innovative use for Perfectus control, as we've recently completed, is a tidal flow traffic solution. Tidal flow refers to patterns of traffic during the day where traffic volumes can require lane direction changes to facilitate efficient movement of large traffic volumes. The Aston Expressway is a classic example of the system, along with ALR or all-lane running motorway sections. As we apply this technology to our standard urban environment, tidal flow can be used on a route where, in normal times, simple two-way traffic can be operated. As the sign shows green arrows to proceed or red crosses to prohibit lane access, traffic flows normally. If, however, our route is subject to large traffic volume in one direction, whether it be general rush hour traffic or, for instance, access to an urban area for a sports or entertainment event, the traffic can be converted to a two-lane one-way system with tidal flow operating within a larger traffic guidance system. The wider system can advise drivers to follow the specific route toward a destination, and then the tidal flow system, in conjunction with route alterations, can assist in moving large volumes of traffic into and then out of a specific area. This tidal flow system has recently been implemented in an off-highway scenario by SWACO for Peel Ports at the 12 dock development in Birkenhead. A three-lane access is used for freight ingress and egress from ferries. So as the docks are emptied, the traffic is biased to two-lane exit with one-lane entry, and then it's switched to two-lane entry with one-lane exit for new cargo as the ship is prepared for its next sailing. The scenarios and solutions we've explored thus far are all based on the interaction of vehicles with vehicles or vehicles in the environment. These interactions can be dangerous and costly, both for those involved and those affected, but thankfully, the inherent safety of vehicles that have been developed over time to protect their occupants means that our primary focus has been on supporting their safe passage. With micromobility and non-motorised users, our focus is different. Micromobility has developed as a sector in recent years, covering not just cycles but also scooters, now increasingly prevalent in urban environments where people of all generations are being actively encouraged to move to cleaner forms of transport. Add to that the presence of NMUs or non-motorised users, and a vehicle interaction with an MM or an NMU is brought into ever sharper relief, especially as we move into an area of shared spaces, whether it be cycle routes on roads, cycle superhighways that intermingle with the traffic highways, and semi-pedestrianised town centre spaces. Pedestrian warning has always been a core element of the SWACO safety signs range. In its simplest terms, pedestrian warning is used predominantly for school pedestrian traffic, with the sign utilising an onboard timer to activate flashing ambers around a retro-reflective warning symbol and associated message. The timer function is accessible by onboard Wi-Fi, meaning the client can access the controller configuration interface to upload a new schedule, amend the schedule already on the sign, or make simple override deactivations. The calendar function supports a 3-year schedule, enabling the client to prepare sign disabling during planned holiday periods. As local authorities are always under pressure to save resources, the ability to disable the signs from operating for an extended period not only supports that resource saving, but also helps the local authority to demonstrate to residents and drivers that they are using their best efforts to save what everyone perceives to be their tax contribution. A natural development of the simple timer activated sign is to utilise an MVD within the sign setup to provide detection of approaching vehicles during the timer period, activating the school or pedestrian warning. This can be particularly useful in more rural locations where traffic may be lighter, but again, regular visitors to the area can feel that resources are being wasted if a sign is permanently activated during a timer period. In this case, MVD activation of the display during a timer period can provide a simple solution where the sign is activated for approaching drivers within the specified periods and the sign can stand dormant outside of those times. Of course, the natural extension for this system is that the overlaid display can be utilised to provide maximum value for clients. During the timer period, the sign can either permanently display or feature an activated display to warn of pedestrians. And outside of the timer period, the sign can activate a speed warning from the MVD input, thus ensuring again that clients are able to extract maximum value from the system. Pedestrian warning is often a solution to a site-specific challenge, and at SWACO we've been able to contribute to the conventional solutions such as those previously described, along with less conventional. Retail parks feature a host of specific challenges where drivers are often concentrating on other aspects that are site-specific, such as looking for access to areas or parking options. Add to that the fact that pedestrians are occasionally distracted with sight awareness and navigation to a destination, often with children or family in tow, and the potential for a hazard situation is increased. The video clip you can see here is an installation we prepared for a retail park client who were looking for a solution to deal with a particularly difficult interface between drivers and pedestrians. When a crossing features the standard Belisha beacon, but is placed within an environment where there's many visual distractions, the beacon can be hard to differentiate. So we were able to provide a system where detection was fitted to overlook the entrance areas at each side of the crossing as well as on crossing, providing an output to a warning sign along with activated road studs when a pedestrian moved into the vehicle area. The key to a system like this, as with a lot of the hazard suite of products that we've already discussed, is that system detection and output can be retrofitted around an existing crossing. In the event that the site provider is faced with a happy problem of increased footfall, they're able to mitigate the potential hazard by installing a system without having to close the access route. Cycle detection and warning has been a growing sector for several years now, with SWACO at the forefront of this sector. We've supported projects such as the A38 cycleway with signs that utilise the close contact input to support existing technology partnerships between the local authority and specific equipment providers, meaning that the infrastructure rollout isn't impeded or hindered by subjecting the local authority or route operator to costly and time-consuming development projects as an important part of the system. The detection is already tried and tested, and we were able to marry this to class-leading display technology. Our input in this field was increased with the co-production of a project to bring cycle detection and warning to rural routes as part of a partner project with Central Bedfordshire Council. We were initially approached with a brief to design a system that would warn drivers that cyclists may be in the road ahead on a route that was partially obscured by high hedges, a feature of the local countryside, on a road that acted as a shared space for vehicles and cycles, as the route is on the National Cycle Route Network. Design and development of the system moved forward quickly, thanks to the valuable input of a long-time supplier who was specialists in cycle detection equipment, and in conjunction with our client and their desire to utilise a design of sign that properly conveyed the presence of cyclists as a potential hazard to drivers in both directions on the chosen route, the design was finalised and installed in December 2018. The system utilises cycle detection from AGD mounted on the sign at each end of a monitored zone. When the cyclist passes through the detection and into the zone, two detection inputs are created. A radio trigger is sent to the sign at the far end of the zone to interact with that sign's MVD, ensuring that any drivers entering the zone are aware that a cyclist is in the road ahead of them. The second input is held on the host sign's controller, again to interact with that sign's MVD to warn drivers approaching the sign that a cyclist may be around the next corner. Each sign then used default resets to ensure that the system was primed for each cyclist entering the zone, with timeouts configured against cyclists and inputs from the detectors and radio units. These signs also featured dual display previously described, in this case using the diagram 512 bend warning as an overlaid element in the warning triangle display. While cyclists were the primary focus of the scheme in planning, it was acknowledged that drivers were still an important part of that assessment equation, and that the safety of drivers was still compromised by the restricted visibility into the monitored area. So the use of the MVD to warn drivers to slow down for the bend ahead was also implemented to ensure that the end user got maximum value from their asset. With the increasing focus on micromobility solutions for urban infrastructure, the utilizations of solutions of this type can become increasingly important at micromobility hubs. In the planning stage, the efficient movement of private traffic, public transport, pedestrians, cycles and scooter users presents specific challenges to planners. So a combination of shared area detection and warning solutions can hopefully provide long-lasting benefits for all involved. Traditionally, the assumption has been that the provision of mains power would be required to support the kind of complex solutions we've highlighted during this webinar. But that's an assumption that's at odds not only with the environments where we've seen these solutions work at their best, such as rural junctions and traffic accident black spots, but also with the fact that as we move toward a more sustainable future, the ability to design and provide solutions that do not rely on fossil fuel energy generation has become much more desirable to us at SWACO, as well as our clients and the general public who interact with the solutions in the longer term. Those of you who subscribe to Highways magazine may have seen an article submitted recently by SWACO where sustainable and off-grid solutions are discussed, and I just wanted to reiterate some of the points made in that article. People often assume solar and solar wind are the only solutions available, as they are solutions most often seen at the roadside. But it's precisely because they're the most visible solutions that we're most aware of their presence. Solar and wind solutions have to be carefully considered at the planning stage to ensure that the location is suitable for that solution. Solar energy solution is still reliant on a good open south-facing aspect to ensure optimum energy generation, and wind generated solutions are often compromised if there are surrounding structures or obstructions, whether they be man-made or natural. Of course, if trees are present at a proposed location, we would never expect that they will be disturbed, never mind removed, as we are as aware as everyone else of the effect that this has on the natural habitat. So we have to consider our solutions carefully. Solar provision is still our primary aim if the location is suitable. The resource is always available, even in the British climate, and development on the batteries used for storage of solar energy allows us to provide solutions that are resilient in even extended periods of inclement weather. Couple that with careful planning and execution of the solution provided, and we can satisfy both the requirements for equipment that has been optimized for low power solution like our displays, but also provide for equipment that isn't designed to that low consumption target, but is invaluable for its functionality, such as stop line detectors included as part of the solution shown on screen at the moment. The stop line detection shown in the current image on the right is coupled by a radio link to the display shown on the left, warning approaching drivers that there is a vehicle either waiting to pull out into live traffic or is in the process of pulling out into live traffic. The solution shown is much like those already described, but the point I wanted to reiterate is the combinations of stop line detection and radio activation and then radio receivers and displays are at the higher end of what will be considered a solution for a sustainable source of energy, and yet the system is in the field working as we'd expect. Sometimes the power supply requirements for an off-grid solution can reach the point where a standard solar or solar wind solution is no longer practical. When we reach this threshold, we're able to introduce fuel cell technology. Fuel cells utilize methanol combined with air and water in a process known as coal combustion to produce a clean and safe source of energy as a result of the electrochemical process within the fuel cell, often as a backup to a standard sustainable power source. As you can see, we can provide suitable, sustainable solutions for even the most extreme of operating requirements. An RGB sign, as shown here, requires display performance unlike any other sign in our portfolio, as often the display can be on for many hours as a message is displayed to motorists to warn of a hazard, a diversion requirement, or even to publicise an event. The sign here features solar power as the original power supply provision, along with batteries to store that generated energy, along with a fuel cell backup for periods of inclement weather or extended darker periods during the winter. The power provision also supports scheduled communication to a remote monitoring in-station to allow power consumption and fault data to be downloaded and messages or displays to be uploaded. Hazards on the highways take many forms, from natural hazards caused by the local topography and landscape, through pedestrian and non-motorised modes of transport, through to private passenger and heavy freight and commercial passenger transport. And every scenario needs its own considered solution. Hazard warning is never one size fits all, and even with a system that is seen as a defined solution, such as OVDs, there is still a lot of consideration to be made in the preparation of a successful solution, from detection placement to diversion rerouting, provision of power, and if that power is an on-grid or off-grid solution. And in the rare event that there's a problem, how do we minimize disruption to local drivers and residents and ensure that our vital infrastructure isn't unduly disrupted. Hazard warning systems aren't a magic bullet that can be applied to a problem and be 100% successful in all cases, but we have strong evidence that well-planned and efficient systems can provide lasting benefits to road users and the authorities that supervise and maintain these systems. Systems need to be resilient and reliable in the worst conditions, and at SWACO we've always endeavoured to provide not just off-the-peg systems with a proven track record, but also systems that utilise equipment that we and our clients are familiar with to ensure that their own engineering and on-site support teams are able to maintain and diagnose issues and rectify them quickly, thus ensuring that our solutions continue to provide the safest solutions for drivers that we can provide. As a company, we are proud that we're able to offer robust solutions in the most trying of conditions, with signs and detection systems that meet the highest standards required for the UK highways. And as we move forward in an ever-changing landscape for transport, we will always do our utmost to ensure that drivers and clients alike can rely on SWACO to provide the best safety solutions on the highway. Yes, we. I mentioned in the script that we offer remote monitoring for all of the Profectus suite of products. So you're able to, as I say, either upload configuration, download data from MVDs, monitor power supply and power levels, and also keep an eye on minor and major fault records. Preferably 2. We've done 3, but once you get to 3, if you've got 3 different images being carried by fixed LEDs on a sign display, it gets crowded. And because we follow the guidance that where you utilize, say, the pedestrian crossing symbol or children crossing to a school symbol, for instance, the recommendation is that that is filled rather than outlined. So it does get a bit busy on the display. So often, if you're looking for more than 3, then we would start looking at probably a full VMS solution. But yeah, 2's completely convenient. 3 is doable, depending upon the symbols and the size of the symbols that we're working with as well. On or off periods, on or off periods is infinite. You can literally set a different protocol for each minute through the day, should you choose to do so. But that would make for a very unwieldy config file to work with. What you can do with the school signs is you can carry up to 8 different day types on the sign. So in the config for the sign, you can pick days as weekends, you can pick them as bank holidays, in-house school training days, that kind of thing, and just pop them into the schedule when you first prepare the schedule for upload. So of course, you may not know how far forward your school training days go, for instance, but you'll know when Easter is in 2 years' time. So you can prepare all of that standard calendar for weekends, Christmas holidays, Easter holidays, etc., and just upload that as soon as the sign is first configured. And under normal operating conditions, the sign will just continue to work from the calendar and then probably activate, say, 7:30 until 9:30 on a morning, 11:30 until 1:30 lunchtime, and then 3 p.m. until 4:30 on an evening during your normal school attendance days. Any other questions? In that case, we're done. Thank you very much for attending, everyone. I hope to speak to you all soon. If you have any other questions that come up as a result of what you've seen in this, but you haven't wanted to put the question in, obviously you can email me at paul.wright@swaco.com. You'll be receiving, I believe, a link for the recording of this session. So again, if there's anything you want to review from the recording and then send an email back in, you're more than welcome to do so. But if that's everything, then thank you very much for attending, and we hope to see you all soon. Thank you. Goodbye.